Hello, this is Matt Heizler from New Mexico Tech, and I'll be presenting at the Virtual Goldschmidt Conference results related to 4039 geochronology of muscovite in the context of an MDD model. Recently, we have published muscovite age spectra, where we have recognized rising spectra with age gradients ranging from about 20 to 70 million years. We have used the multi-diffusion domain model to describe these samples using argon 39 release to obtain the kinetic parameters as shown by the Arrhenius plot in the upper right hand corner, inverting this Arrhenius data into a log R naught plot using the activation energy of Harrison 2009, and then deriving thermal histories for model spectra that well match measured spectra. These thermal histories seem to well fit with other thermal chronometers from the same rock samples, where we have zircon and apatite results, both fission track and helium, showing that the derived muscovite thermal histories well conform to the rest of the thermal chronology data. We also conducted a very simple experiment where we took a large Precambrian muscovite and ground it and sieved it into 3 grain size fractions ranging from about 45 to 212 microns. With these 3 grain sizes, we heat treated them in vacuo prior to irradiation at temperatures between 600 and 800 degrees C approximately for durations of 1 hour to 10 days. We then irradiated the samples and step heated them, and then we conducted multi-diffusion domain analyses on the results. What we found is that, as predicted by volume diffusion, the higher the heating temperature, the greater the argon loss for a given grain size, as shown on the figures on the right, as well as for a given temperature, the smaller the grain size, the greater amount of argon loss. Both of these conditions are predicted by volume diffusion, where volume diffusion is controlled by the physical grain size of the particles. We took these results of all the samples and we inverted them within the multi-diffusion domain framework. That is, we used argon 39 to determine the frequency factor or diffusion coefficients based on an activation energy of 63 kilocalories. We then imposed on this determined diffusion parameters the known thermal history, i.e. how long the samples were heated in the laboratory and at what temperature. And what we find based on the model spectra shown in red in the top figure, that the model spectra very, very well match the measured spectra, suggesting that this inversion via the multi-diffusion domain framework returns the known thermal history. We also wanted to evaluate the effect on the apparent kinetic parameters due to heating in relative to the unheated sample. So shown here are the Arrhenius plots for all of the data, and what can be observed is that for the most part, the unheated and heated samples have identical diffusion parameters as calculated from the release of argon 39 in vacuum. Thus, the concept of dehydroxylation or physical change to the samples appears to not be occurring in a significant way throughout this temperature window, and or the process of dehydroxylation does not impact the volume diffusion kinetics relative to a non-dehydroxylated sample. From our data sets, there are multiple observations that support that degassing in vacuo is a volume diffusion process. Measured age spectra commonly have inflections indicative of MDD behavior. Arrhenius data derived from 39 argon loss are well described by an MDD model. There is a direct relationship between physical grain size and degassing behavior. Model age spectra closely match measured age spectra utilizing an MDD model. Known laboratory-induced thermal histories are recovered with the MDD approach. Thermal histories from geologic samples derived via the MDD approach are in agreement with multiple other thermochronometers derived from a single sample. These observations, in our opinion, strongly support the release of argon in vacuo via a volume diffusion mechanism. So we are left to ask, if it is not a diffusion mechanism, then what is it? What other mechanism can explain all of the observations. This we conclude is not a random process or a process that's not described by volume diffusion. Thank you.